Hello everyone. In this part of video, I'm going to discuss some of the numerical that is not in the form of the waveform, which is not a sinusoidal waveform. So for this kind of waveform, how we can find the RMS value and average value. So let us see, this is a waveform. A generalized waveform is given. 20 volt is here maximum, minimum 10 volt, and the time is given is in millisecond. This is millisecond, this is also millisecond. Means for 10 millisecond the voltage is 20 volt, and another 10 millisecond the voltage is 10 volt. Again another 10 millisecond the voltage is 20 volt. Then another 10 millisecond voltage is 10 volt. So voltage is changing here. uh, so we have to find in this problem, it is required to determine the effective value of a voltage, effective value of voltage, effective value of voltage. Effective value means we have to calculate RMS value. Effective value means RMS value. So here to root mean a square, we need the a square of the value. So I draw here another plot. Squaring this to 20 square means here 400 volt will be there, and a square of 10 will be here 100 volt. So this work is done. A square of the voltage here we have done. Now our task is to find the time period of this waveform. So what is the time period of this waveform? If you see, it start from here, going here, coming down, then going here, then coming here, and then again starting the same thing. So here you will see that its time period, that is denoted by T, which is equal to 20 millisecond. Time period is 20 millisecond. यानी कि 20 multiplied by 10 to the power minus 3 second. Time period is this much. Means wave start here, then go down, then go here, here, and then again same thing is repeating here. So this much time is called the time period. So we know time period and also a square of the magnitude. We also know the area under the square curve from 0 to 10. If we see area from, this is time is 0, time period is 10. So area of this waveform, we have to calculate the area from the 0 to 10 second. So what is the area from here 0 to 10 second? This is 400, and time is 0 to 10. So 400 multiplied by the time period will be the area of this curve. So if you will remember our definition of RMS value of voltage and current, what was that? It was 1 by T, 0 to T, V square into d omega t or dt, d omega t. This was our basic definition of RMS value, and root is also applied here. So this is given as RMS, means a square, then multiplied by the time period, and then we have to integrate, means we have to get the area under this curve, area under this curve. So from 0 to 10, if we see what is our area, means here 400 area for 0 to 10 millisecond. What is the area? 400 and multiplied by this time period. So area will be for 0 to 10 millisecond, area equal to 400 multiplied by time period is 10 into 10 to the power minus 3. So this is the area from 0 to 10. Again we have to find the area between 10 to 20. So area between 10 to 20 millisecond. 10 to 20 millisecond, our area will be, if you see here, 10 to 20, what is magnitude of the voltage? 100. So it is 100, and time will be again 10 millisecond, 10 into 10 to the power minus 3. So these are the two areas. That is, this is the area we have all. This is the value actually we have calculated. This value, taking some different color. So actually this value is now calculated for these two area multiplied by time, a square of the voltage, this voltage is 200, so 410, it becomes 100. So now total area will be the summation of these two. So total area will be equal to how much? Just taking some other color. So total area will be equal to 400 into 10 to the power 10 into 10 to the power minus 3 plus 100 into 10 into 10 to the power minus 3. So it becomes 500 multiplied by 10 into 10 to the power minus 3. So this is the total area. Now this term is calculated. So now we have to divide it by time period. So dividing by time period, what is this time period? 20 millisecond. So now I am going to find this value dividing by time period. So dividing total area divided by time period. So time period is how much? Time period is 20 millisecond, and this is 500 into 10 into 10 to the power minus 3 divided by 20 millisecond, 20 into 10 to the power minus 3. So this term cancel, this cancel, and it comes 250. So up to here we have calculated. Now this value is this value calculated. Now RMS value will be equal to, now root under, only we have to apply root here. So a square multiplied by time and divided by the time period is calculated. Now Vrms will be equal to now only we have to apply root. So if by taking that root of 250, we will get its value is 15.81 volt. So in this way we will find the RMS value. Same way, if we want to find the average value, you can also find the average value. That is also very easy. RMS value is calculated, average value we can also find. In another problem, we will see how to find the RMS and average value by taking the some different waveform. So I'm taking another example. So this is one example based on our for average value and RMS value. In this question, it is required to find IRMS and I average and also form factor these three things we have to find out. So I already told you, okay, whatever value is waveform is given, first of all we have to find its time period. So the magnitude of the current is 10, and it start 10 go 20 second 2 second, and then from 2 to 3 second its value is 0, again it goes up, and 3 second its value becomes 10 ampere, and again the same thing is repeating here. Whatever value is this waveform is going like this. So here by seeing this plot we can see its time period is t equal to 3 second. So its time period is 3 second. So now we have to find RMS value and average value also. So for to calculate the, first of all I am going to calculate average value. Just define 1 by t, 0 to t, I, and d omega t. Here time is, so dt we can write, and this is nothing but this is the area under the curve of the time period 0 to t. In integration, this is the average value, and in integration this value is nothing but this is the area under the curve of I and time, and period is 0 to t. So here in 0 to t period we will see that how we can find this value we have to find. So from 0 to t we see that from 0 to 2 second its value is its area. We have to find 0 to 2 second area, 10 multiplied by 2. Area will be 10 multiplied by 2. And from 2 to 3 second means for 1 second, what is its value of what is the value of current? So area from 2 to 3, here value of current is 0. So current multiplied by time period is 1, and divided by This is the area total, means this portion is calculated. Now what is time period divided by 3 is the time period, so this is the average value. So after solving this, we will get its value is 6.67 ampere. So average value is now known. In similar way, we can also find the RMS value. IRMS. Just we recall our definition. What was the definition? It was 1 by T I square into dt 0 to T, and then taking a square root. So first of all, we calculate this value for the time period 0 to 3 second. So let us calculate it. So I square means for 0 to 2 second, current is I square into time period is 2 plus from 2 to 3 second, what is its current value? Current value is 0, so 0 square into 1. So this whole value is now calculated. This thing is whole value, this whole value is now calculated, just taking a different color. So this value is area, this is now calculated, which is equal to this much. Now we have to divide it by time period. So what is time period? 3. So up to here now it is done. Now again we have to take its root. So this is taking its square root, and this value is coming 8.16. So now we have also calculated the RMS value and average value calculated. Now the question is form factor, KF. We have to find KF, that is called form factor. Form factor, which is defined as IRMS by I average. IRMS by I average. And RMS value is 8.16 already calculated, and average value is 6.67. So if we divide it, we will get it 1.22. So this is the our two problem which I solved by directly using the integration method.